Hello, am I audible?
Yes, ma'am, you are.
Okay, thank you. So we'll just start off with the session in next 4 minutes. By the time let's everyone join, then we'll just start off with today's session.
अबे हाँ कॉल तो रह जाती है वो भाई जो मेरे फोन में कि बार ना क्या नाम है टेम्पर टूट रखा है जब मैं टाइपिंग करते करते ना जब उस पर टिप हो जाता है ना तो मैं जाता इसलिए मोटर
Everyone, please make sure that their mics are muted while they are in the session, okay? So please maintain the decorum of the session.
Yeah, hello guys. Is my voice audible to you?
Yes, ma'am.
Okay. So we'll start with the presentation. Is there anyone who wants to present?
Ma'am, let me.
Yeah, sure. Harsh, you want to present your project?
Yes, ma'am.
Okay, so after him, you can just go ahead with the presentation.
Ma'am,
Shivani.
shall
Yes, ma'am.
Yeah. Okay, so Shivani, you can go after Harsh. Okay.
Okay.
Yeah, Vijay, you can just share your screen and start your presentation.
okay, ma'am. Is my screen visible, ma'am?
Yeah, it is visible.
So, good evening, everyone. My name is Abhijay, and today I've made an EDA project on on the topic student performance. So, the primary objective of this making this project is to find out the key factors which are affecting the overall academic performance of the students. The dataset consists of 6 columns. That is student ID, weekly self-study hours,
Vijay,
percentage.
uh, Vijay, your voice was breaking in between. Just start from beginning, a fresh, like do a fresh start. Okay.
Okay, ma'am. Ma'am, am I audible? Is my voice clear now?
Yeah, it is clear. As of now, it is clear.
Okay, so good evening everyone. My name is Abhijay, and today I've made an EDA project on using PG admin, that is PostgreSQL, on the topic student performance. The primary objective of making this project is to analyze the key factors which are influencing the overall academic performance of students. So the dataset consists of 6 columns, that is student ID, weekly self-study hours, attendance percentage, class participation, total score, and grades. So as you can see that table here, the student ID. So after that, I have just calculated the average performance using. I have just calculated the average performance using the average function. So let me just run it. So as you can see, the average self-study hours of the whole class is 15 hours, and the same I did with the average attendance uh, of the students. So which is coming 87.84.71%. Here you can see the same I did with the class participation. Uh, uh, so I can run this also for you, which indicates 5.98. That means there is mm, that means there is basically less average participation of the students. Here, I did a grade analysis using group by function. Uh, I've used as I've used average function. Average. I have used average function to calculate weekly study hours, average attendance percentage uh, on the basis of grade. Let me just run it. So you can see. The individuals with who scored A grade, their average study hours is 19 hours and average attendance is 84, followed by the ones with B grade with the average study hours of 12 hours and 84.69 percentage, and the list goes on. Then I've just found tried to calculate the correlation between class participation, class performance. So you can see the correlation between participation and performance of the students is 0.001 It signifies that there is no correlation between participation and performance. And the same I did between total score and weekly hours, and the result is coming 0.81 per 81. That means there is a high degree of correlation between total score of the students and their weekly hours. The same I and the same I did with between total score and attendance percentage, uh, but it's coming in minus. That means there is negative correlation between total score and attendance percentage. Then after I did a grade distribution, I was just selected the grade on the basis of of the basis of average study hours, attendance, and average class participations of the students, and thus I just ordered them on the basis of the grade. So let me just run it. Here you go. Uh, the one who have scored a grade, their average study hours is 19 hours, average attendance is 84.71, and their class participation is 5.98, um, which is basically higher than the uh, following classes. Then I've just uh, uh, stacked up the students on the basis of their performance using group by function, and let's run it. As you can see, the higher performer students with the are with the average study hours of 20 hours. Their average attendance is 84.7, and their average participation is 5.98. On the average participation of all the three tiers are basically same. Then I just tried to find out the top 10 uh, top performers of the classes. Let me just run it. As you can see, so that's all, ma'am.
Okay, but based on your project, it is totally on SQL. So you need to do the chart plotting and the other details in R, right? So you haven't gone ahead with the R programming part.
Actually, ma'am, I've never used our program prior, but I will
That,
definitely try to.
okay, but the project was related to like it was the combination of all of three, the SQL, the R, along with the Excel part.
Okay, ma'am.
So you need to just work around and do the implementation of all. Okay. But SQL wise, the data that you have taken from like, so how you have just taken down the data in SQL? So you got the data from where? Kaggle?
Yes, I'm from Kaggle.
Okay. So how you did that? How you just taken the data in SQL?
Ma'am, actually, the problem I was facing was regarding the data type. I was just that somewhere I was putting the limit of 10, but the actual, we can say, variables were proceeding the limit that is 15. So that was the issue, ma'am.
Mm-hmm. Okay. Got it. So that has been resolved, right?
Yes, ma'am.
Okay. So, so try and extend the project to the part where you can try and use the R programming along with the Excel part. Excel basically for creation of the dashboard and seeing through the data actually. Fine?
Okay, ma'am.
Yeah.
Ma'am, anything
So
else?
you can, no, the project requirement was like that only. So you have to perform it in that manner.
Okay, ma'am. Thank you, ma'am.
Okay. Okay. You can just stop sharing your
Okay, ma'am.
screen. Okay. So next is Harsh. Harsh, you are there.
Yes, ma'am. Am I audible, ma'am?
Yeah, you're audible. You can just share your screen.
On screen visible.
Yeah, it is visible.
My name is Harsh, and my project is crop yield production, and its area is in agriculture. The project focuses on the analysis and prediction of crop yield using real-world agricultural data. The core objective is to understand how key factors such as annual rainfall, fertilizer, and pesticide affects the total production. So, so here first I have created SQL data table and imported data from CSV file using import data wizard. After, after that, I have check check for the data type and description of the table here. After that, I have checked for total number of rows in my database in my table, and total number of rows is 19,689. After that, I check for the distinct unique distinct crops and total number of states that are there. Now in a data cleaning part, first I have added first I added 5 column production in metric tons and annual rainfall in fertilizer in ton, pesticides in ton, and yield per unit area column name. After that, again I have checked for the description of the table, and here you can see all the changes are there. And in while adding columns, I have used after to get accurate position of the table column where I have needed. After that, I have updated tables. Here I use SQL safe update command to temporarily block safe mode, stop safe mode. After updating my database table, I have re I have automatically on the safe mode, and again I have checked for the and again I've checked for the description of the table, and after that I have checked retrieved all the rows of a table. As here you can see it, all the rows are there, and I have converted pesticides and fertilizers that are in kgs in original database to in tons, and yield I have used it in per unit area. After that, moving on to a data processing part. First I have selected First I find the average of total number of records, average pesticides. Sorry, not here. First I count total number of records, total count of distinct crops, total distinct states, and minimum crop year and the maximum crop year that are there in the dataset. After that, I found I, after that I find an annual state-wise yield trends for every state and every year that are there in my dataset. As you can see here, for Bihar, I have all the data from 1997 to 2019. After that, I have find data of average rainfall versus average yield by state and season. Here you can see Andhra Pradesh in in Kharif season receives 920 mm of rainfall, and its yield is 4.35 metric 35 unit per production per unit area. And while they're in Rabi season, rainfall decreases to 916 mm, and and during and in as you can see in Arunachal Pradesh or in Assam, rainfall typically remains same overall in whole year. After that, found I have I found top 10 crops by yield state wise in national top 10 crops that are mostly produced in our country with most average yield. Here, coconut, sugar, banana, potato, onion are the top 10 crops based on their average yield. After that, I have found the impact of fertilizer on yield state-wise. Here you can see in Puducherry, low small quantity of fertilizer is used in compared to Mizoram, and the yield is multiple times higher than that of Mizoram. And in you can see in Delhi, more in Delhi, that is in Delhi, average fertilizer used is significantly smaller than Sikkim, and the average yield of Delhi is higher than Sikkim. After that, I find relation between pesticide usage and yield by state. Here, you in average pesticide used in Goa is significantly higher than that of Puducherry, and the average yield is increased but not that much. And the area in Goa, the agricultural area is also very high. So we can say pesticide uses doesn't affect total crop that much. As you can see in West Bengal, average pesticide usage is 60,000 tons, while average yield per unit area is significantly lower than that of Goa. Now here we are moving on to yearly change in fertilizer application and its effects on yield. Year-wise use of fertilizers. In 1997, this table is organized by crop year in a descending order, ascending order. Sorry. Here in 1997, average fertilizer use is significantly higher than that of 1998, but average yield is higher than average yield is also higher than that of 1998. Now moving on to the R studio part. First, I have imported necessary libraries. Then I have connected my SQL database to the R studio using DB connect function. After that, I have used DB get query to get all the data from the crop yield table. After that, I've cleaned and prepared the data. For example, in fertilizer, we have fertilizer are there in kgs, so I have converted them in tons. Yield, area, fertilizer. After that, I have plotted and using ggplot, I've plotted annual average yield by state, and that is it is my plot average annual yield by state. As you can see, most average annual yield is is maximum is of Goa, then that of Puducherry. After that is West Bengal. Now second plot is yield versus rainfall. As you can see here, getting most amount of doesn't increase yield. As you can see, mostly the yield is higher when the rainfall is between 1000 mm to 2000 mm of rainfall. So we can say here that excessive rainfall also affects the yield of a crop, and minim and less rainfall also affects it. After that, in a third plot, I have used fertilizer in tons versus yield. And you can see using excessive fertilizers also decreases the yield of a field. As you can see here, most yield is of when we are using less number of fertilizers. And here, as you can see this dot where we have excessive used fertilizers, but the yield is that not that much. Now the fourth plot is of state versus annual rainfall. So here I have plotted the rainfall with state, mean of rainfall of each state. As you can see, Meghalaya receives most amount of rainfall than that of Haryana. and Delhi. After that, I have used predictive modeling to to get the prediction of the yield, and after that I have done model evaluation. After that, I have say exported my result to a desired location and saved it in a CSV file format. After that, I have disconnected the SQL part. Now in Excel part, this is my raw data that I have gone downloaded from Kaggle. After that, in this I've cleaned it, and you can see area in raw data is in that we doesn't know what unit it is in. So I have mentioned the unit in a column next to the area column, and the same with that is of production. After that, in a rainfall is also same, but in fertilizer and pesticides, fertilizer and pesticide are there in kgs, so I've converted them into tons. After that is a yield column, and this data is what after this is the data that we have downloaded, we have that we get from our programming part. Here we have get the predict yield that we have predicted in a different column, and it is somewhere in some column it is close to the yield that we have get, but in somewhere it is way off than that. As you can see here the predicted yield is 1.22, while we have get 6.2 units per unit area production. After that, I have plotted average rainfall and average rainfall based on state in and I have used slicers based on season. For example, in autumn, Meghalaya gets most amount of rainfall, and in Kharif season, also Meghalaya gets most amount of rainfall, but most number of states in India gets the rainfall in that season only. In Rabi, in summer, as you can see, number of states that get rainfall is decreased. After that, here I have plotted pie chart for max production of each crop based on year, where I have used slicer for in each state. As you can see here, rice is produced 31%. Rice contributes total 31% of the total yield of the Arunachal Pradesh, and oil seeds are there for 21%. Same that in Bihar, you can see sugarcane is produced most. After that is a wheat and rice. In sheet 6, I have created a dashboard where I have used these two these two plots from my R programming part and this also. And here I have used previous plot, average annual rainfall plot that I have used there. And this pie chart is what I have used in sheet 5. Thank you, ma'am.
Okay. So can you just go to your R programming first?
Yes, ma'am.
Yeah. So here, how many plots you then have you
4, ma'am.
calculated? Four
4.
plots. Okay. Okay, fine, great. So after that, you did the prediction part, right?
Yes, yes, ma'am.
Okay. So you have used which model for prediction purpose?
Ma'am, actually, I have got this idea of this from Perplexity. It's my second day using our programming.
Sorry, I didn't get you. Can you come again?
Ma'am, actually, it's my second day of using R programming, and this part, prediction part, is
Hmm.
there. I have got this from AI ChatGPT.
Okay. So you haven't like learned it and implemented it, right?
Yes, ma'am. Due to time, I have used it from ChatGPT. Otherwise, I am going to learn it.
I got it. Fine. So it's nice that you tell me the truth. That's why I just asked you like which predicting model you have used. That's nice
Yes,
that
ma'am.
you have told, but eventually, like that's fine what you have used, but you can just make it better when you'll be just getting like spending time with R and learning R. Okay. So
Yes, ma'am. Yes,
eventually, if you have time, so you can just like since your the actual and the predictive data are not same, so there is a loss that is coming up that is huge, right?
yes,
So you
yes, ma'am.
can just fine tune it and work it accordingly while you start like understanding R and working and practicing with R.
Yes, ma'am.
Okay,
Yes,
okay,
ma'am. Yes.
and just go ahead with the Excel part. Yeah. So first of all, the dashboard, you need to just clear it up a bit because it is not looking uh, that in that form. Like you can't present it to someone, right?
Yes, ma'am.
So it is not looking like it is not looking that way that you can just present it. So you need to organize it because things are not organized up here. And go
Yes, ma'am.
down in your dashboard. Yeah, here. In the pie chart, the datas are getting overlapped, right? So you got the option in when you have just created it, you just get an option of putting this inside your plots in that format. So you try
And
and do it
yes,
like
ma'am.
here also it is getting
Overlapped.
like messed up
Over.
because
Yes, ma'am.
overlapping is because there are multiple of
Oh,
sections that is there.
yes,
That's
ma'am.
why the overlapping is happening. So you
Yes,
can
ma'am.
just like not just from here, you get an option of formatting also. Try
Yes,
and
ma'am.
format this part because things are getting more cluttered. So
Yes,
while
ma'am.
visualization purpose, it is not getting that like in that format, we are not
Looking
getting
that
that.
much nice.
Yes, yes. And eventually, when not only just nice, if wants to get to understand about the result in details, then also like the results are not visible, right? So in
Yes,
that
ma'am.
form, I'm saying. So and how many plots you did for this Excel part?
Two plots I have done here and used these three plots from our programming part.
R. Okay, got it. So you just go ahead with the first, like the original data that was there, your that you have just downloaded up from Kaggle, I guess.
Yes, ma'am. This
Yeah,
one.
this is the data. Okay. So again, the formatting thing that needs to be done. Okay. Next,
Yes, ma'am.
go to the clean data. Yeah. So okay. So you do have the crop year. Then what you are
Yes,
having?
ma'am.
I can see it.
Season.
You just
Season.
okay. Season. Then states
Then
area.
area.
Okay, so area wise, that what you did, like your area to converting it, how you have converted, like what to
I
what
have
you have
not con
converted.
I have not converted it. The area is already in hectares, but we
Okay,
don't know what unit area is in. Unit of
okay,
area. So I have
okay,
just
so
mentioned the area unit.
fine, got it.
Same
So
same with
in
the production, annual rainfall.
okay,
In fertilizer and pesticides, I have converted kg to ton.
okay, fine. So only change that you have done that is in the ton part. Remaining the remaining you have just added the matrices like where because that
Yes,
was
ma'am.
unknown, right?
Yes, ma'am.
Okay. And before yield, what you have got? The production, right?
Mhm.
Okay,
Yield.
okay,
Yield per
uh,
unit area.
okay. Okay, yield before yield, that is okay. Pesticide upon
Yes.
tons. Okay, fine,
Yes,
got
ma'am.
it. Fine. Okay, got it. So I just needed to see the data because you have got many other options also, like many other fields are also there. So you can
Yes,
try
ma'am.
and include other charts as well. Like the chart can be that bar graph or that
I
like the pie
I
chart.
had tried, but
Yeah.
the data is too large that
Mm-hmm.
the bar chart is looking
I got it.
nice.
So I understand, but try and include like top five data, top 10
Yes,
crops in that format. You can try and use.
as
Okay. Yeah, I
as you can see,
understand.
ma'am, the data for cotton,
Mm-hmm.
coconut is significantly higher than that of than
Mm-hmm.
the rest. So
Right.
using coconut completely distorts the bar plots
Mm-hmm.
that I have tried to plot.
I understand. I understand. So only the coconut was seeing, the like other plots
Yes,
are not coming
yes,
up
ma'am.
for
Other
bar,
plots are
right?
not. Yes, ma'am.
I understand.
Yes, ma'am.
So now you can just try and you can use the pie chart only, that is fine, but try and use the top five or top 10 so that you can segregate it. Because here in this
Okay.
form, if you are just putting the datas also, it won't come up in that form. Okay. Try and segregate
Yes,
in a
yes,
form
ma'am.
that you can just get the top five data, or you can try and use any other format to check it through, like if any other. So here what you have done, like this is against crop. What is the yield you have got
Yes, ma'am.
or the production? Okay,
Max production of
maximum
each
production.
crop. Yes, ma'am.
Okay, got it. So you can first do one thing. You can just slice it down for the top five or top 10 crops in that format. And you can just, like here also, as you have used the slicer in the dashboard, also add the slicer so that
I have added
it
it,
can be
ma'am.
changed. Yeah. Okay. So
You can
since
pull.
okay, got it. But since the plot is not looking that fine, try and add up to like level it up to at least top five or top four in that format. Okay.
Okay, ma'am. Okay, ma'am.
Okay. Anyway, it was a nice presentation from your end. So whatever the details that because in the prediction part, loss, the
The
average, the actual and the prediction is there is a difference, huge difference that is
yes,
coming up, right? So you
yes,
need to
ma'am.
work with that. Rest, it's fine.
Okay.
Okay.
Thank you.
Okay. Yeah, you can just stop your screen sharing. Next is Shivani. Shivani, you're there in the session.
Yes, ma'am.
Yeah, you can just present your screen and
Okay.
start your presentation.
Hello, ma'am. Is my screen visible?
Yeah, your screen is visible.
Okay. So, hello everyone. My name is Shivani Sadani, and my topic is crop yield prediction. So, here the objective is to predict crop yield for different crops and regions using historical data and understand key factors affecting crop yield, uh, like rainfall, soil quality, and fertilizer uses. So data sets I used are three data sets. There are soil data, weather data, and crop yield data. So for soil data, there is it contains state, year, soil type, nitrogen, phosphorus, and potassium. For weather data, it contains columns, name, state, year, rainfall in millimeter, temperature in degrees Celsius, and humidity in percent. And crop yield data column contains state, year, crops, fertilizers, kg per hectare, yield per kg per hectare. So in BigQuery, for SQL, I use BigQuery, and in this for I used it for cleaning data set, and then further I will analysis in R. So for cleaning the steps, I remove duplicates using select distinct for all the three data sets. And for handling missing values, I imputed average wherever required. Then I join all the three tables for creating a master table so that I can analyze it further. And to simplify analysis, the three tables were joined on state and year. So as a result, as a result, a single master table is formed combining crop, soil, and weather information. Then I did basic exploration, average yield per crop. So average yield for rice is almost 3,796, wheat is 3,285, and maize is 3,533. Average yield per state, highest is for Andhra Pradesh, which is 3,571, and lowest is for Maharashtra, that is 3,540. So this is my SQL part. Now for analysis, I used R. So here the objective is to analyze the combined master data set to understand the relations between crop yield and factors, influencing factors, and build a predictive model using historical data to forecast crop yield based on soil, weather, and fertilizer parameters. So I started with loading the data. I used the library read R, and then I loaded my data, and I for then I did first view the first few rows. For that I use the function head of data. Then for checking the structure of data, I used str function. So this is my summary of data, which says yield per kg, per hectare, minimum is goes 3,001 13, and maximum it is 4,040. Fertilizer kg maximum used is 250 and minimum is 50. Rainfall minimum is 400 mm and maximum is 1,388 mm. Temperature is minimum 15 and maximum is 25. So for checking missing values, I used is an a function, and I found that there is no null values or missing values. So for visualization, I use library ggplot. So my first distribution is yield distribution. For this, here we can see yield per kg per hectare. So histogram shows that most yields clustered around 3,500 and 3,800 kg per hectare. Then I use scatter plot for fertilizers versus yield, and it shows that there is a positive linear trend observed, and higher fertilizer often corresponds to higher yield. Then I use correlation analysis, and for this I use library core plot, and it shows numerical variables such as fertilizer, nitrogen, rainfall, and temperatures, so varying degrees of correlation with crop yield. Then for predictive modeling, I use linear regression model, and the formula I used is yield per kg per hectare is approximately equal to fertilizer per kg per hectare plus nitrogen plus phosphorus plus potassium plus rainfall plus temperature plus humidity. So this is my model summary, and we can see that their nitrogen positively impacts crop yield significantly at P less than 0.5, and RMSC, that is root mean squared error, is 255.64, which is not so good, which it signifies that lower RMSC indicates higher predictivity accuracy, and so linear regression is not showing good predictivity. Although I have stored this predictive data for further analysis in Excel. So I have used the R data, which shows the predictive yield column. So first analysis is yield per state. uh, and we can see that Kerala constitute the higher yield with 24.07% and Maharashtra 22.9% are top, and Bihar contributes the least with 15.35%. My next chart is yield versus rainfall per year. This is a line chart. Yield remains relatively stable despite rainfall. Suggests rainfall is not the sole driver, is not only the factor which is influencing the yield. Then I did fertilizer versus yield. It is a scatter plot. It shows a positive but non-linear relationship. Beyond less beyond 150 kg per hectare uses yield plateaus, indicating an optimal threshold for users. Next chart is for average fertilizers uses per state, and for this I have used map chart. And southern states like Kerala use more fertilizers than northern states. Then I have made a combo chart. This is a combo chart for predicted versus actual yield. Predictions for rice are highly accurate. Small deviations in maize with higher scope of and wheat. So this is my dashboard, which shows here there are five KPIs. First is total average yield with 3,567 kg per hectare. Average rainfall is 945 mm. Average fertilizer uses is 118 kg per hectare. Crop performance ratio is 1.01 and prediction accuracy is 255.64. And these are the charts I have analyzed before, and this is a slicer which I can use for analysis. So that's all about my project. Thank you.
Okay, Shivani. So your dashboard looks good. And can you just go ahead with the predictive and the actual yield, this part,
Yes,
that
ma'am.
chart?
This is a combo chart. I have used a pivot table using the column uh, crop for rows and average yield per kg per hectare as values and average of predicted yield as values. And then I used the combo chart.
So have you just sorted it because only three values are coming because rice, maize, and wheat other details are not coming up. So you have sorted it, right?
Yes, ma'am. I have
Okay.
filtered it out and then sorted it according to descending order.
Mhm. Got it. Fine. So based on that, so only three data you are getting. So there is some of the deviations that can be seen, right? So the predictive average is quite a bit same for all of it, but that is like they're different from the actual yield, right?
Yes, ma'am. Actually, in R, which I have used a linear regression, the
Mm-hmm.
model is not good for predicting. Because,
Okay.
yes, ma'am. But
So the
also,
RS,
yes,
RSMA value you are getting higher. So you need
yes,
to
ma'am.
put it down to lower.
Yes,
Got it.
ma'am. I
So
didn't, I
yeah,
had
yeah.
no time to use another model, so I presented it.
Okay, not an issue. So you can just try and fine tune it, okay?
Okay,
And try
ma'am.
and use, if possible, try and use any other form to, like any other model to work with it and see how the data are coming up. And if possible, you can just compare it as well, right? So you can try
Yes.
and compare between the two models. Like for this, you are getting like linear regression, you are getting the result like that, or if you are trying and using any of the tree-based model, like how the results are coming, you can just try and compare that as well. So
Okay, ma'am.
just show me the model ones in R.
This is my model, linear regression model. and this is the formula.
Okay. So you have taken yield per hectare.
Huh.
Based on that, you have taken into account the other details, right?
Yes, ma'am. Other factors such as fertilizer, nitrogen,
Mm-hmm.
phosphorus, rainfall, every factor.
Okay. Okay, fine. So if you if you get time, try and just like fine tune it. Fine.
Okay, ma'am.
Yeah. Okay, Shivani, you can just stop your screen sharing.
Thank you.
Yeah. So next, who wants to present?
Yeah.
Is there anyone who want to present their project? No one? Fine. We'll just start with the session then. If no one is there to go ahead with the project, then I'll just start with the session. But guys who have done with the linear regression part, that's fine. Uh, if you want to, or if you can, try and fine tune it. And who have not done with the R part, they have to do it in R programming only, because Python programming, like the project that has already been done, this is dedicated like religiously to the R programming, this project. So you have to use SQL, R, and Excel in that format only. You have to work it around. Okay, so you can't use Python for this. Fine. So we'll just move ahead with the session. My voice is audible to you, and like my screen is visible. Hello, guys. Can you
Ma'am, you
just
are
let?
audible, but your screen is not visible.
Okay, fine. Got it. Just a moment. Now,
No, ma'am.
okay, just a moment. Visible?
Yes,
Screen is
ma'am.
visible? Okay,
Yes,
got
ma'am.
it. So we'll just move ahead with a blank one. So we'll first just recapitulate what we have done in the previous session. Then we'll just move on with Power BI and Tableau, because today we don't have much of the time. So we'll try and cover some bits related to the Power BI part, maybe the interface, and then we can try and move ahead with the other sections. Okay. So today we, like last day, we have just came up with about the data visualization part. After we did the ETL part, next we have moved on to the data visualization. So after we are done with the ETL part, now this time we need to, this week we will be focusing on the visualization and creating interactive dashboard based on the data. So what is the reason of creating the interactive dashboard? What is the need of data visualization? First, the very first question that comes to mind, that is, what is data visualization? So let us just go ahead with like data visualization. So data visualization is the process of turning the raw data that I am having into a visual forms, that can be anything like charts, graphs, and plots, anything that is there. We can take account with that. Okay, so that is actually data visualization. So how we are turning that thing, that is the vital question. So we have used Excel. So in Excel, what we did, we have got the data, we did the pre-processing, or we have cleaned the data. Basically, we can say it like that. We got the raw data, we just cleaned the raw data, did some of the major pre-processing that is required in the data. Then we have just used the pivot table and pivot charts to create interactive visuals based on the data that we are having, right? And eventually we have just, after we have created those charts, we have just segregated them in one place under one roof, so that we got a report, everything in a report form, and we have just made it connect with the slicer so that it becomes interactive. When suppose we need to check it for a specific data or specific time frame, we can do it, right? So this is actually is the part. So we are done with the dashboard making in the Excel part. So now we'll just see how it looks in case of Excel. No, sorry, in case of Power BI and Tableau. So before that, we'll just note it down the points why do we need to data visualization, or why data analysis is needed, right? So we'll just take down few points on, uh, because we need that, because it is easier to understand. Suppose we are having some of the data, and the data are expanded in a form that we can't just see it and understand what this data are signifying, what are the inner trends that are there inside the data. So if we just use the data visualization in case of data analysis, it becomes easier to understand. Like, right? Human understand pictures faster than the numbers. And getting any of the data down, suppose I have this data. So from this data, what you people will understood, like what you people will get in through, like why this data are, what is the reason of this data. So just few lines. So if you just convert it into proper, maybe any of the pie chart, you try and understand, like suppose based on the crop section we have seen just now. So how the crops are distributed over the, like maybe the regions of India, and how the yield has been affected, that we can see from the plot. So this is the very first need of data visualization, because it is very easy to understand. Next, we can identify patterns and trends with the visualization. That is very crucial part, because from data, just by seeing data, we can't understand the intricate details and the patterns that are actually there inside the data. So we just need to identify the pattern and trends that are there inside the data. That is the reason we need to take into account. Next, we can make the comparison easily. Suppose we have got some of the chart. Suppose we have a bar chart side by side, and we have a pie chart side by side. So we can try and compare between them, like the same under the same, suppose pivot table, we have plotted two different charts. One is a bar chart, another is a pie chart. So from the data, we can try and get the different insight, but the technically the details would be same, but in some perspective we get some of the insights that are just like giving some of the extra edge based on the chart, so we can just try make comparison easily. So the very first or foremost reason of just converting the data to charts, graph, and creating a dashboard is that it helps in decision making. There are big companies who take decision based on data. So nowadays, data is everything. Data is the money. So we need to work with data. We need to take data driven decisions, so that we just get the actual result out from that. That's why we need to take data driven decision. That's why creating creating the dashboard is the prime requirement. Next, we can detect the relationship between the variables. We can detect the relationship between the
Excuse
features.
me, Avipsha.
Yes, ma'am. Yes, sir.
Uh, did you shared anything? Because I can see only the blank sheet.
Yeah,
Uh,
I have just shared the blank sheet. I have just not written it, because we have already studied this before, because 2 days we have just gone with this presentation stuff. That's why just recollecting the previous thing, and we'll just move into the Power BI part. So just for recollection purpose, I have just shared the details.
Okay, fine, Abhipsha. Carry on.
Just for recollecting, that's why I have just shared the blank screen. So we'll just
Okay,
after this
okay,
we'll
okay.
just
Please
move
carry
into the
on.
Power BI. Okay, got it. So we can detect, as I was saying, we can detect the relationship between the variables and definitely communicate the insights effectively. So hopefully, guys, all this we have covered, so it is clear up to you, right? Understood. We'll just move ahead to the Power BI part now. So this is the Power BI. So we'll just take a blank report up so that we can see how we can take into account with the details. Okay, so these are visible to you. The screen is visible to you.
Yes, ma'am.
Okay, fine. So we'll just move in with the interface of Power BI, because might be there are many one who haven't worked with Power BI, just like many of you haven't worked with ours. So maybe like that. So we'll just go from scratch. So here you can see in the top section, we have got the option of save, undo, redo. This options we get, and get the option of saving, like the name of the file that I want to save it through. So I can just change it to any of the form that I can try and do. So after I perform any of the function or any of the operation up here, I'll just save it with any different name. If not, it is just kept it as untitled. Okay. So here in the top left section, we have this options. Next, in the extreme left, we got the views, different type of views. So the very first one, that is the report view. So we can check in on with this report view, like how actually they look and how is the form that we can take into account. Uh, so we can see that there is a report view. Next, there is a table view. So you can see this is the table view. This is the model view. That this is the tax query view, and this is a TMDL view. So what are all this? We'll just discuss in details. So what report view is? So report view is you can see this one. So this is the report view. So this is the main interface for creating. Like here you can do all of the functions and all of the stuff that you can do. So here it is the main interface for creating the visuals in Power BI. Okay. So here you can try and create like charts, graph, table, whatever be the details, maybe a dashboard, what you need to create, you can create it. Okay. So we can think about the features that we can take it out from here. So we can add multiple of pages up here to form a report. So it is kind of similar to Excel, but you got the option of creating sheets. Here you got the option of adding on to different pages. Okay, so you can customize the visuals like the colors, the labels, the size that are there. You can try and connect with that. Next is you can apply filters, the slicers, whatever be there, you can try and create with that. Okay. So we need it basically to convert what is the use of it. So we need it to convert the raw data into any of the easily understandable visuals. So for this part, we are needing it. Next is the data view. This one is the data view. So sometimes we call it as the table view, like it is written as table view, but we call it as data view also. Okay. So it actually what it actually shows all of the raw data that we have actually imported. So we'll see one by one. So first is the interface. That's why I'm just explaining it down while be going in deeper and working with the details. So you can just get in details about the views as well. Okay, so how each of the section works and how you can take it on and understand about it. Fine. So here also the data are displayed. So in this one here you can just display about the different charts, the different dashboards, what you have created. But in case of table view, you got the visuals of the table in the rows and column format, just like in the Excel. Okay, so what it allows you to see the data, it allows you to inspect the data, it allows you to clean and transform the data before you are just creating the visuals. So you know you have seen an Excel, right? Before we have taken down the raw data, then we have just gone ahead, created like worked with it, did the pre-processing, then only created the visuals like the charts and stuff. So based on that, here in data view table, you get the view of the entire table so that you can just see like the pre-processing can be part can be done in this form, like what pre-processing you did, that can be seen here. Next is the model view. So this model view, what it is, model views, it shows how like different tables in our data set have been connected. Suppose instead of just importing one file, I have imported two files, and they must be connected with each other in some form, right? So this model view shows the different tables in the data set that are actually connected. Suppose I am using the same data set but trying in using two different or three different charts. Maybe in the form of CSV, I have included it. So it just tries and create the relationship between the tables. So it's like the join table. In SQL, we have learned about joining the different tables. So model view also shows us like that, like how two tables are joined within each other. Okay. Next is the DAX query view. What is DAX? DAX is the data analysis expression. So it is a formula language. You can call it as a formula language in Power BI. So this is the part where we can write the formulas to just create new measurements. Suppose any columns, new calculated columns you want to add. Suppose you have a data set that is the sale data where you got the values of the unit price along with the how many unit of that product has been sold. So you can try and add another column that says the total purchase of that very specific item. So what you'll do, you'll just add the total, the unit cost of that very item with the number of items that has been brought. So you get the total costing, right? So or the total purchase, whatever be it, you can just create it. So for that, the formula that you are writing here, that is the DAX query view. So here you are actually writing the forms like formulas to just create new measures. You can calculate like any of the calculated column or any other table also you can try and create. Okay, so you can just try and create any of the custom table or custom calculation here to get in details about it. Okay, next is the TMDL view. So what TMDL stands for? It is the Tabular Model Definition Language. Okay, so it is actually the code view. Okay, so you can see here it is the code view. So it shows the like underlying data model structure in XML format. So this is actually in a XML format. So it just tries, it is the code view actually. Next, what I told, it shows the underlying data. There might be data that are underlying, or we can't figure it out, or we can just see it through. So it shows the underlying data model structure in the XML format. Okay, so these are actually part of the advanced user or also maybe there are certain problems that we are dealing with that consist of the intricate details and the complicated patterns. So there we need to try and use it through. Okay, so these are all the views that we have talked of. Now I'll just go ahead with the upper section. So these are actually the tabs. So we got a file tab. So it is basically for saving purpose. We can save the file, we can share the file, we can do import, export. This part can be done under this Save tab. Next, we do have the Home tab, Insert tab, then Modeling tab, View tab, Optimization. These are the tabs, like well-known tabs that are there in case of Power BI, and we can try and use it. So it is the home one. So here you can see that there are different versions that are clipboard. Then there is data, there is query, insert, calculation, sensitivity, share. So all of this, what it is, each of them are the groups. And inside each of the groups, we have this actually, this sections exactly what this signifies. They are actually the features. We can call it a feature, right? So each of them are different features that we can talk of. Okay. So inside home, you can see the groups that are clipboard, data, query, insert, calculation. So similarly, in under the tab that is insert, you've got different groups that has different features. Inside the groups, we got the features. Modeling also the same. The view, we are got different views from here, and inside the groups we are getting different other features. Okay. Next, what we are doing, so these are actually the features and the groups, and all of it together, what they are called ribbons. Okay, so they are called ribbons. So lower down, we have got the two options. The very first option is the desktop, and another is the mobile. So what are this? These are actually the view. So we can have a desktop layout view as well as we get an option of mobile view as well. Okay, so if I just click it, so you can see how the mobile view looks. It is mostly elongated. Mostly in the vertical section, you get the view up, and in case of desktop view, you get a horizontal view, and the data are more and the values or the significance are that you can see that it is taking space, and you can just see it elaborately. Right. Next, what you can see, you have the panes. So we have got three panes down here. So here we have got the data pane, like this one is the data pane. This one is the visualization pane, and this one is the filter pane. So what is the work of that? So in the data section, so it is this data pane is called the data section of the Power BI, where we can see all of the tables. Suppose we have included some of the tables, so we can just get a better view of how we can see the like in the form that how what are the tables we have taken down, or what are the columns that are there inside the data set that we can see inside this data pane. Okay, so what it does, it acts like a library of the data. Like as we have the index in the same format, we do have this so that we can just visualize how the data are actually, what are the tables, and inside the data, what are the features that we are including up. Okay, so based on that, the key features that we can just try and list all of the things, all of this together, we can find out the columns and the details. So these are actually the part of data pane. Next is the visualization pane. So it is the section in Power BI that actually creates and customize, like it creates and customize charts. Next, we can create graphs, we can create different visuals. So it actually shows all the types of visuals that we can create from the data. So this is actually the like the visuals part. So here you get the option of build visuals, and you get the format. Like you get a detailed format where you can just customize it, the customize the plots or the graph on your basic understanding, or how you want to plot the graph in that format. You get an option of the built-in visuals as well as the customization part as well. Okay. Next is the filter. So filter, you can think it of as the slicers that you actually use in Excel. So filter pane is where the data is getting filtered, like in the reports or the visuals that you are getting, you can just filter them out. So you can call it as a control panel that decide like what data to show and what to hide actually, because it is actually consists of the filters. So what filters I'll be adding, only that data will be showing up. Less, irrespective of that, the other details won't be seen in that. Okay. So under the features, we have got the option of visual level filter. Next, we have got the filter of page level filter and the option of report level filter. Okay. So these are all about the interface. So interface part is clear, guys. Guys, interface part is clear.
Yes, ma'am.
Okay. So now we'll just see how we can just import the data. So under the home tab, we got an option of get data. So you can click it down. So we get the option of taking it from the Excel workbook. So we can get it from Power BI schematic model. We can get it from data flows that we are having, then data verse, SQL Server, we can take the data. Next, we can take the data from analysis service, text and CSV, web, OData feed, blank query. So all of this, whatever be it, we can try and check. Like we have got multiple of options and it is seamless to use the details in Power BI. It's just like you have to work through, you have to explore each of the features and eventually you can try and work with it. Okay. Suppose for an easy view, let me just get a CSV file out here. So let me get this file, details file. So it is connecting. So now it has just given me the preview. So I do have the data that contains the order ID, amount, profit, quantity, then the category, then the subcategory, and the payment mode. So all of it is actually showing. So here we do get the option of loading the data. Next, I can directly from here also we can go with the transform data as well. So here we can transform the data, but here I have no need of transforming the data. We can also see it later. First, we can just try and load it. So just we have just loaded the data. So you can see it, right? So here you have got the data, and while you click it down, you get the option. So whatever the fields that are there inside the table, that is actually getting viewed. So you have got the option of amount, you've got the option of category, then you have got the option of order ID, then the payment mode, the profit, the quantity, the subcategory, all of it you are getting here. So let me just import another form. Just a minute. The CSV one details I have already taken. Order, let me just take it through. So here I have got the data that contains order ID, order date, customer name, state, city, all of this are there inside this. So let me just load it down. So see here in the data pane, you get the option of the details, what are the fields you are having under this order, like order table that you have created. You get the option of the uh, different, uh, different features that are there, like different fields that are there inside the order. So you can just select it and work with it. So this is the report view that I was showing you. This is the table view. So see here you have got the option of the table view. So here it is showing me the table. So it is showing me this details of the details of the details table. The name of the table is details. So when you are just coming it up, you have shown it, it gives you the information like the name of the table, it shows you the storage mode, how the in what form the storage has been there, like you have imported it or you get it from web, how it has been showed, and when the data has been refreshed, right? So you can just see it. So here, since there are two tables, it is showing the details of the details table. Now just switching on to the order one. So it has already showed me the details about the order. So it has got order ID, order date, or like customer name, state, and city. So we do got the option of filtering here. So you can just sort the data accordingly. Like just like in Excel, you got the option of filtering. Here also you got the option of filtering so that you can check in through. Like you can sort it ascending order, sort it in descending order. Next, just like in Excel, we used to see what are the data. Here also you can see what are the data. If there is any like inconsistency in the data, that you can check it once from here. Now let us just move with order date. So how the order date are, in what format, if you want to put it, sort it out, you can do it for all of it. For this also you can do. Okay. So here you got the option of data order date. So you can just see the data hierarchy. So here you just get. So in what format it has divided the data hierarchy, the years. Year wise it has got divided quarters, month, date. So it just gives you the hierarchy as well. So next let me go into the model view. So it has given me the model view as well. So how actually it is. So what are the details that is there. So here you have got the details and the orders. So it has given me the model view, how they are actually linked. So you can see here while you're clicking it, so the order ID, by what it has been linked, by order ID. So this is the order ID that is there in details table, and there is order ID in the order table. So by this, it has got linked. Clear guys, up to this much, everything is clear. Guys, clear?
Yes, ma'am.
Okay, fine. So this is the data that we are taking into account. So suppose I want to get into details about like we want to get in the other form or other details. Let me just go here. So now we have got this option. Now I am working with this details one, like the details tab. Now we want to suppose change it to in want to transform the data. So the first we have load the data. I have shown you how we can load the data, how what are the features that are there. Now I want to transform the data. So let me just take transform the data, transform data. So a Power Query editor has came in front of me. So what is this Power Query in editor? So this gives me the right to work with this transform data. So I have got this data enlisted up. So I have taken down the, so let me just show you. So this is the data, detailed data I am having. So under details table, I do have the option like the features that are amount, category, order ID, payment mode, profit, quantity, sub quantity. So you can just see here, all of this has came up and with a filter. So here also you can sort it down. You can see what are the options like suppose here UPI is written and another one that is small u, small p, small I in that format it is there. So what you'll be doing, you'll be finding the smaller one and you change to capital UPI so that you can just filter the data around, right? So this is the view and suppose you want to change the type. So how you'll be doing it? So suppose this is my, let me just say it for property. No, sorry, profit. So let me just double click up here. You get the options. So these are the options that you get. So we get the options, different options. That is change type we have got. So here you got the option of change the type to different format. So suppose I want to change it to maybe percent. Let me just click it down. So now I want to replace the current. So see, it has just given me the option that it has just changed the form. It has just changed it into percent, right? So see here, we have just changed the type. So now I don't want it. So here, what it is, this is the query setting table or the part where you get the option of, you can see on which table you are actually working. Next, you can, if you click all properties, it does give the other details like what is the description, what is the details. If it has the description, it will showcase that, and the applied steps. What are the steps that you have applied that will be shown. So here, lastly, I have changed the type of this profit table from numeric to percentage. I have changed, but I don't want it. So I'll just cross it down. So it'll just came back to the normal one. So see how seamlessly we can work here. No formula is needed. Nothing is needed. You just need to understand the interface, and just need to explore the interface so that you can try and work with it. Okay. So next we can just, in this form we do get the option of like removing duplicates. Suppose it will check, like based on column it will check. Suppose if there is any duplicate round in this column, it will just remove that. Next we do got an option of duplicate column. Suppose with this column I want to create another column. Like in Excel, we used to create another column, and then we used to apply that. And like suppose there is small case in every column. I want to change it to uppercase in Excel. We used to do, beside that, we used to add another column. Then you used to use the uppercase formula, and then used to insert that value inside the uppercase. So when the data we are getting, we used to delete the support table, right? Support column we used to delete. So similar way, we if you want to create a duplicate column, same as that, we can just do it by just clicking duplicate column. So see here, it has given me the duplicate column. So this is the support column that I have gotten, and it has, like by itself, it has given the name as profit copy. So this is my original profit column that I am having in my data, and this is the copied version of the data that we have taken into account. So I have no need of it. So similarly, in the applied step, we got the option of duplicate column. I'll just close it. So the data are back to normal. Whatever the data we have taken into account, it is back to normal, and we are able to see it. Clear, guys? Understood? So we don't have much time today to discuss the details. So we'll just discuss the details tomorrow. We'll try and work with it and try to make interactive plots from the data. Okay? Understood, guys?
Yes, ma'am.
Up to this much,
Yes.
is it clear? Okay, great. So we'll just stop today here. We'll meet tomorrow, and accordingly, we'll see how we can work with Power BI. Okay?
Okay, ma'am.
So, yeah,
Okay, ma'am.
okay, great. Then bye for today. We'll meet tomorrow. Bye-bye.
Bye, ma'am.
Bye,
Bye.
ma'am.
Bye.